So we're back again, and the usual reminder, if you look down below the YouTube video in the description, expand it out. We got links to various things, and this current video is indexed, and one of the links is out to our composite index. It has years of indexes for the meetings, and it's got a little thumbnail to show you what the picture looks like, and you can directly click on it there and go to the video if you want to watch it. It's even got a link to the old ROS agriculture stuff where I was indexing that. It's got a couple of years of index on that. And I've got some other random stuff. I think it's got a link to our Slack page and the one to our YouTube page that has all these videos on. And I realize every time I do this, I just make that stuff up. So you get random bits of information each week on that. So anyway, you can go dig through that if you have an interest on that. So as far as what I did this week, last week I was talking about LEDs and LED drivers and so forth, and I don't remember. I should have gone and looked at the index from last week or watched the video or something so I know what I was talking about. But anyway, the second batch of LED driver boards I got was one that looks like this. And you can it's a switching converter. So you can put, I think it says 5 to 30 volts into it. And then you put an LED on the output and it forms a current source. So these resistors on the board here, one of the resistors sets the current. And this, when you buy it, is claimed to be set to 350 milliamps. And when I hook it up and run it, it actually comes out 310 milliamps, which I thought was close enough for what I was doing. And I was thinking about all the things if I wanted to have LEDs wired in series or in parallel, what are my options on that? And one option, you get too many LEDs in series, the voltage required to run it gets to be too high, and in this case higher than the battery on my robot. I've got a 12-volt system, so I could assume it goes between 8 to 15 volts or maybe 10 to 15 volts if I want to be conservative. And it turns out that if I put 4 white LEDs or blue LEDs or green LEDs in series, those are 3-volt LEDs. So it takes 12 volts to light that up. And if I got a 12-volt battery on my thing, part of the time I'm not going to have enough voltage to light that stuff. So I was thinking about, putting, say, 2 of those in series to give me 4 volts, and then put that in parallel with another. So my total of 4 LEDs, I could run on 4 volts. And I think that since I got some stuff in parallel, I would have to double the current from the driver. And since this driver is 350 milliamps, let me come back over here and go to, we'll start here. So if I say share screen, this screen, okay, it says that's going out. Get this out of the way. So this is the board I actually ordered. The board I have in my hand is this one. And you can see they're very, very sparse on the pictures over here. There's the bottom view with absolutely nothing on it. And there's the top view. Oh, it doesn't, it lets me zoom in a little bit. So anyway, you put power in on one end, you'll get your LED up on the other end, and the resistors on the board here set the current. And then it's got a PWM pin, so you can run it from 0% to 100% of whatever current it's set at. So if I hook up a standard 1-watt LED, they say they want 350 milliamps, so you can hook one of those up this directly and still run the PWM to control the intensity on that. And then I thought, if I do that thing about putting 2 LEDs in series in parallel with another 2 LEDs in series, then I need 4 volts to run that, but now I need 700 milliamps in order to do that. So I thought, well, I could hack this board, try to replace the resistors on it. And then I had an inspiration. I went back to Amazon and said, search for 3-watt LED, 3-watt LED driver. And I found these boards, and the board looks close. You can see the traces are in different spots, so it's not the same board. And the difference I notice is the inductor on the board, it now says 101, and the other board said what, 470?
Yes, 470.
This one says 470, and this one says 101 on these. And then also the resistors are, the 3 resistors are different values that was on the other board. And they claim this puts out, it's set at 700 milliamps. So it works the same way if you put in, see, how do I get rid of this? Then if I go through and look at it, well, I wonder if it's the same chip. And if you go out here far enough, come out to this one and zoom in on this, if you look at it from just the right angle, it turns out, yes, this is the same chip. So it's the XL4001 E1 driver chip. So what it means is, yes, indeed, they just changed the resistor values and changed the inductor, and otherwise it's the same thing, but it puts out double the current. So in that case, I wouldn't have to hack my little board I've got now. I just get some of these to give me twice the current. And then if I wanted to, let's see, anything else we need to know about this? And I'll probably put a link out to my old board, my new board in the description, just so you know what's going on here. Anything else got to know? So that'd be a solution right there. So without hacking my boards, I can double the current and get it to where I want. And I don't know if I just mentioned, but if I take one of those 10-watt LEDs, it says it'll go all the way up to 1,000 milliamps, and I was running 800 milliamps, and it was pretty darn bright at 800. And if I hook this board up, it'll put out 700. So it's putting out almost, it's putting out like 3/4 of the current that this wants. So I could get a 10-watt LED to light up using these two. So that'd be probably a worthy investment. I get 6 for $16 there. And again, you go here. Let's back up a page. So I just simply, my search term was 3-watt LED driver. And these are the first boards that I had, these little ones here, which are, they're the low voltage. See, down here it says you put in 2.9 to 6 volts and you run a single LED, or you can run multiple LEDs in parallel. And if you run them in parallel, then you have to crank up the current. It's got a little pot on there. Now let's go look at it. So it's got a pot on the board, each one of those. So it's got a pot and a resistor and a chip. And the resistor is just to set a minimum, so you can't set it all the way down to 0 ohms. Then you can turn that pot, and I think it says it goes between, I don't remember what the low range was, but it goes up to like 1.5 amps it'll put out. So if you're willing to have a low voltage input to this thing, that will work. And last week I discussed putting a switching converter in front of that. And I guess there's really nothing else to know about this other than they do work, and they seem to do exactly what they're supposed to. So let's back up. So here's the new one that popped up. Like, hey, I can just buy one off the shelf that sets at 700 milliamps. So it was this is the one I was just showing you before, and this has lots of pictures. It uses the same driver chip. It just has a different inductor and different capacitor or different resistors on the board. And so I could do that, and that could work out for both my the 100 or the 10-watt LED, or when I start doing resistors in series and parallel combinations, I can use that. And just looking down here, it was turning up different stuff that I'd seen before. Now you got to be careful, because the stuff at the top is all through Amazon Prime. In fact, there's a checkbox right here. See, on the in the upper left, it says all Prime. Now, not all the screens have this, but if you click on that, that shows you ones that will that has this at bottom, says, oh, it's through Prime, you get free shipping, like 2-day delivery or whatever. And it'll go down a ways, and it'll be a much shorter list. And well, here's some that say, no, I guess it's still doing it for some reason. It doesn't, the green thing is not showing because those are on sale or something. But anyway, that's another handy thing when you're searching for stuff on Amazon. So I guess that's maybe all I need to say about that. Oh, and then I came down and that's where's the 10-watt ones. Now the 10-watt ones, maybe I have to get them from China. And this one, that's a 5-volt 7. So this is another 700 milliwatt or milliamp board. And I see it's fairly expensive, being almost $6 for a single board. And it's got these funny short pins. But if you look down here, the delivery date is October 27th through November 10th. So you can't get it through the Prime delivery and get it in 2 days and get free shipping. And then down here, here's another 10-watt. another 10-watt driver. And let's see, I didn't look. This apparently this one's coming direct from China, but also you can. So that's saying you can just get a board. How would I do this like that? So one side's got a lot of components on it. The other side just has an inductor and a capacitor. And this one looks like, with all those big diodes on there, I didn't look at the description, but it looks like this one you could probably put AC. Yeah, 12 to 24 volt. No, they don't say that. Somewhere, I'm pretty sure this one. No, it says input voltage down here. It says 12 to 20 volts, 4 volts DC. But with all those diodes on the input, I'm assuming that's a, you could probably put AC into it, so it wouldn't care if you put in 24 volts AC or 24 volts DC. But that's something else. I didn't know you could buy a little module like this that'll do the 10-watt LED boards. So it's just more things. Again, fun with Amazon searching. Here's that same board again. And they got all these big modules too. And I've never looked at any of those to know what they're doing, because I was just trying to get a little board to drive LEDs directly on my robot for a flashing beacon. So that's all I really cared about. I'll have to remember, this might be a quick if I need to go look up other ones. Oh, let me just make a note here. Let's see. So they had some kind of sale on Amazon yesterday, and that prompted me. I opened the trunk and said, "Here, start throwing stuff in there." And one of the things I did, I bought a one of those ESP32 boards. That's the bigger one that has like 40 pins on it or something. And those are usually too wide to plug directly into a normal proto board, because that way you can either get pins on one side or pins on the other side because it's too wide to fit. And if you look at these are the little short proto boards. And this is the only one I found that had the picture I was looking for, because I wanted to be able to take the power bus off of one side on one board, the power bus off the other side on the other board, and put the two together. So you got two of these butted together, and that way, and you can also move it back and forth on your whatever your base is, and get it so. Let's see, do I have a way to do this? Well, let's look at this one first. So I was here. Let's do this. So this is the picture I wanted to see. They show you the main board, and they say you can see this power bus is taken off. It's got little tabs to hold it on. This power bus is taken off and flipped over. So that's the only people that were smart enough to show, yes, you can take those off. So if you were to take this thing and say, just get rid of this, just don't put that power bus on. So you take the center section and another center section, you now got a different pattern. So you'd probably still want to have some gap in between. You might be able to run one power bus between two of these main ones and get that to fit. And if it won't fit, then you can take both power buses off and just simply slide the two center sections back and forth until they line up where you want them. And I think these have like adhesive back. Yeah, right here is showing this adhesive backing on it. So you just peel this off and you can stick it down to a piece of plastic or whatever you want. So that's something that I had that inspiration yesterday, that I was going to order those boards. And yes, I know they're not going to fit on a single, just a regular proto board. Let's go to this one, because they're wide enough that one row of pins on your ESP32 are up against these holes here. Yeah, so they're in the last whole set of holes there. And then over here, it leaves you like one row of pins you can plug into. So it does not work out. But if you've got two of these, you could put, say, one row of the ESP32 into here, and then have another board here and put that into the side there. And then it leaves you all like an extra four pins on each one. So that's just something to keep in mind when you go to look this stuff up. And since this is the only one that guaranteed to do it, I ended up buying a package of 16 of these for $20. So I'm going to have a good supply of these. And I find these are handy because you can take it and cut a piece of plastic that's the same width as the proto board, and maybe half an inch longer on each end, and then peel off the adhesive and stick it to your piece of plastic. And then you can just drill holes to mount that down to whatever you want. So that's a convenient way. Because once you stick this stuff down, it doesn't want to come off and go on to something else. But if you stick it permanently to say another plate. And you could use plastic, or you could use some old printed circuit board, or even a piece of aluminum to do that with, just depending on what you're trying to do. That's just more fabrication tips on that. So let's see, I was talking about these boards. I forgot where I was. Maybe it was this screen. So anyway, the point was, you can buy this as either a 1 watt driver or a 3 watt driver. And I was pointing out, maybe this is where I was. Yeah, this is where I was. This prompted me down here. This is some crap I was ordering yesterday, so that reminded me of that tip of the day. So we come back up here. We go here, and basically the board. You can tell the pattern of the board is laid out slightly differently. And, just when they ran traces and uh, power planes on the board, and so, but otherwise it looks like it's pretty much the same. And see, neither type have mounting holes, but they've got holes on them such that, let's see, maybe I'll come back to that. So anyway, I was looking at the comments down there, and one guy said, "Oh, when I got my boards," he said the capacitors had fallen off the board. And, oh, that seems odd. So I was looking at his picture here, and it looks like, you don't see any solder in the holes, and you can see just a little bit of solder on the pins. So it looks like they stuck the things in, but they didn't. I assume they do this after the fact. So they wave solder the whole board with all the small parts on. Then they put the big capacitors in, and somebody sits at a table with a soldering iron soldering them down. But anyway, I thought that was kind of funny that he got these capacitors had fallen off. I usually have problems where somebody would put this type of capacitor, but it's a surface mount, and they'll solder down the board. And then when they kick around in my junk box, it it rips the thing loose from the board, the solder mount ones. But that's not the case here. They had them stuck through. And if I get a slightly bigger, it looks like it might be a little blob of solder on the end of those. But he said he ordered like 10 were like this. So that's just more manufacturing problems you run into. And so let's see, we looked at, and then it has 4 1 watt LEDs in this. One is red, one is blue, and one is green. And they also put a white one in here. And the ones that Al ordered had the red, green, and blue inside, but without the white. And then they bring all these out to the pads out here. We can get to them and solder them together. And I may use those on my thing, or I might get some of the big 10 watt slash 3 watt, however they want to term those. And let's see, we looked
Be
at
able
this
to see that from space.
That was the intent, but if you get it bright enough, you can back the power off and then not have it get so hot. And then I was noticing on Arduino Nano, which I would tend to lean towards, it's got 6 PWM software, PWM outputs, so I could drive up to 6 channels of my LEDs. So if I put all this in a single box, put the LEDs on the outside, put the driver boards inside, and put a microcontroller inside, I can either talk to it with a USB cable or take the UART pins and run those out if I want to talk to it from my other microcontroller, that's what I'm doing right now. Is my main microcontroller is taking care of that. And it
And
turns
that'll
out,
just give you dimming, right? I mean, if you want to mix, I don't remember my colors. If I want to mix blue and green to get yellow, I still have to do that some other way, right?
well, you will not mix blue and green and get yellow. You'll get a blue green. If you mix red and green, you'll get a yellow.
There you go.
And I think you're pointing out that if you ran uh, close to 100% on red and then like 10% on green, it would give you a yellow. But yeah, you can just through the PWM just tell it, one's 10%, one's 100%, and that you can mix your colors that way. If it's your thing to flash, you just say set PWM to 0, and then you want to turn it on, set the red one to this one, the green one to this one, and that'll flash it yellow. So yeah, once you get the dimming on there, you can control each individual one all the way from off to on. And if you want to do flashing, that's one layer of code. And you want to mix them, that's another layer. So
So
you
the
would have,
dimming is changing the current or the voltage?
it's technically controlling the current by PWMing the the width of the thing. So it's controlling the current, which effectively, well, no matter what you're controlling, that controls the intensity.
Interesting.
And the
Okay.
voltage will be the maximum voltage, and it's either all on or all off at the maximum, not the maximum voltage, the maximum current. And your LED, if it's a 2-volt LED, it'll run at 2 volts. If it's a 3-volt, it'll run at 3 volts. So you don't, basically you don't worry, especially if you got a constant current driver, you don't worry about the voltage at all, as long as you stay within the range that lets it light up 100%, and then you're okay, should be okay on that.
Interesting.
So the other thing I had open here, here's the data sheet for that board I was just talking about. And it says, here's how you build a battery charger, but more important, it says, here's how you build an LED driver. And so I assume they just took this circuit and put it on that board. It's missing that capacitor. They're saying 100 microfarad, they're putting 220 microfarad on this thing. And so here's this thing with these 3 resistors. And if I look at it hard enough, they're saying to set the current through the LED, it's just 0.155 divided by the value of this resistor. And the resistor's on, I can't get a combination that makes that come out, but it does run at the right current. So technically you have to, if you wanted to change the current, probably this one, this RCS. And I can't imagine, they got a little tiny surface mount resistor. I can't imagine how they push that much power through it to get it to work. But anyway, that's I've got the data sheet for this, and the board that Al bought. We found the data sheet for that chip, and the ones that look like this, I found the data sheet for these. So it's the information is out there, and nobody seems to want to give you a schematic. This one, the schematic on this one says, here's your chip, here's a control resistor, you hook it up and it works. And then they give you some funny stuff there. And the one Al has, there's more on the schematic, but again, it comes back to the fact you can control it with say we're right here. No, right. So basically his board has something like this RCS, it's what do you call it, resistor current sense on his. If he wanted to, he could change that and change the maximum current. Or am I thinking of the other board? But whatever he got, his board is set to I don't know if he's gone back and checked this. He was telling us what the currents were running at, but it was actually the currents on his power supply, which don't match the LED. Did you go back, Al, and check your LED after that?
No, I would needed to pull out my multimeter and figure out how to measure amps, and I didn't do that yet.
Okay, so but it looked like what we're looking at the last meeting, he showed a close up of the board. We took that resistor value, ran through the equation, and it came out to like 357 or 347 milliamps is what it says based on that resistor value. So I'm guessing if you look at it, it's going to look close to 350 milliamps when you run that. So let's see, what else did I have open here? Oh, so I was saying last week, I saw some of these solar lights like you put along your sidewalk. Say here's an example of putting them, people put them along their sidewalk like that. And I was thinking that back in the day, I was looking at them, and I went over to Dollar Tree, and I could buy one that looked just like this for either $1 or $1.25, back in the old days. And it looks like, if you look at the how can I get this? There we go. So on the top, it's got a solar cell here. It's got a battery inside. It's got an LED pointing down. Then it's got this bump in the bottom. It's like it's a little plastic shape, and it's got a mirrored surface on it, and that spreads the light out to the side. So I was thinking, well, it'd probably be worth it if I could buy these for $1 a piece, and they take that plastic thing out. If I only need one, if I use my take my I can't show you right now because I'm screen sharing. Oh, here, if I take one of these and just have it pointed up, and then put the plastic dome over the top of it, that might work out well. Or if I use the what they call the 10-watt ones, the square ones that have 3 red, 3 green, and 3 blue LEDs in it, that would be another one. It simply, that might put out more light intensity, I don't know, but then putting that thing over the side, it seems like that would disperse the light to the point where that might help out. So I was thinking if I get one of these and put that over the top, that might allow me to just have a single LED pointed up, as opposed to right now I've got a metal box, and on each side of the metal box I've got LEDs on, pointed out each direction. And this way I might be able to switch back to a single LED and get it to diffuse or disperse, just simply reflect out the side and be able to make it brighter from the side. So I was looking at that, and I went into the Dollar Tree, and since it's Halloween, you can't get ones like this anymore. You can get a stake that has got like a pumpkin or a ghost or some weird skeleton or something, some kind of molded plastic crap that they're trying to sell. It will still light up. It has an LED inside, but it's not meant to be a light. It's just meant to be cute. So I didn't get anything from there. And I was looking on Amazon, and here they want to sell me, I think 20. It's a 24 pack for $32. Or you can get, I think you can get, is this the 16? That's the 16 pack for it's also $32. That's interesting. So anyway, you could buy them that way, but I don't want to pay that much to get one, especially just to play with. I don't want to do that. I'm thinking I've got some boxes over here that I brought in for my car that might have 1 or 2 of these in. So I'll have to dig for that and see what I can find. So I think that's all I had to say about the LEDs this time. I didn't mean to spend anywhere near this much time, but that's where we are. So I've wasted time. So let's move on. And then I've got this, here's just an example. Come on, stop it. This is an example of, let's go to this one. This, I think, is the one I ordered. This is the one I ordered just yesterday. But it's a board, and this board is inside of a plastic box to keep it insulated, since it's got 110 volts you have to put into it. And it's got a split core transformer on the thing, which means you don't have to cut your wire to put it on. You can just unsnap it, put on the wire to snap it back on. And then it also they give you a USB to TTL converter cable, and that plugs right into the end of the board. So that solves a lot of your problems. And what I started with was this one. We'll call it this one. See what it looks like when we get there. Come on. Why were? Oh, because that's what I'm looking at. So I won't switch to it. So I originally ordered this one for around $13 to $14, and because I'm cheap, I didn't get the split core transformer. So it's just got a solid core with wire wrapped around it. Here's the 2 wires that have to hook onto the 2 terminals here. So what you have to do, you have to go out here. You have to go out and you have to cut your lead, put the core on it, and resplice the lead back together. And if you got these ones that snap on, you just simply unsnap it, put it around the single wire, and snap it back on. And see, this one also didn't come with a case. So what I did was I bought that setup, and I bought a long. Assume we're done with this. Stop sharing. And is it going to come back? There. Okay. So I bought a 3-foot extension cord on Amazon, and I purposely I wanted to test my refrigerator, so I wanted to make sure I had one that's rated for the 15 amps. So I bought a cord that was specifically a 15 amp 3-foot cord, and then I just came along here and cut the insulation off to expose the 3 leads. I got a green and a white and a black, and it put the transformer. I had to cut the black lead, and I slid the transformer on, and see, it's just loose on there. And then I put crimp terminals here, and this board also wants 110 volts AC into it. So I brought up 1 lead and combined it into, so this lead goes into the black lead. It's got three of those crimp on terminal. I put a number 6 screw to hold them all together, and then taped it up. And I had to get the other lead, so I came down here to the white lead and just stripped off the insulation and wrapped my other one on and soldered it together and taped that one up. So it took me way too long to put this together, but it's basically ready to go. I just have to hook something up to these 4 leads here, which is just like a TTL serial interface. So you have to put in 5 volts in ground, and you got to transmit and receive. And if you look on Amazon, they got, or not Amazon, look on YouTube, there's tutorials for basically anything you'd ever want to hook this up to. Or if you got the one that's the USB to serial cable, you can plug that in directly, and then some guy has written up some Python code, so it'll display directly on your PC, on a laptop or say a Raspberry Pi. So I ordered one of those yesterday, just out of frustration on this first one, and then back to the point of the clip-on one. Oh, it just fell on the floor. So you have a clip-on one, rather than cutting the wires, you can still, here's just a little short extension cord. This is just one of those that if you got a outlet strip, it's meant so you plug this in the outlet strip, then put your wall wart hanging over here, because otherwise you plug a wall wart in your outlet strip and it takes up 2 or 3 slots. So they sell these to do that, and I just had one laying around, so I just cut the insulation off. There's my 3 wires exposed. So all I have to do is pull that out like that, and just clip on my clip-on transformer, and that'll solve the current part. And I thought, in order to get AC into the board, I thought, well, I just run a separate cord. So here's just this probably is an extension cord. I wanted to make sure it had the polarized plug on it, where you got the one tab is wider than the other. But anyway, I got that. I can just hook these 2 wires right to the board. So then when I'm ready to go, I just go to my outlet and plug this one in the outlet and plug this one in the outlet. And that way it'll give this will give me the power to run the refrigerator. This will give me the power for the board, and that should work. So it'd probably be a much simpler way to do that. And these boards put out all kinds of stuff. They put out voltage and frequency and current and watts and power factor, and it will accumulate your watt hours used. You can go ahead and say, send a command, say reset that to 0, and then let it run for 5 minutes or 2 weeks, and come back and get the number that it used. So it's just, it's a really clever thing. And the one I bought, that was the board in the plastic case, and the plastic case solves the problem. You're not gonna immediately short it out against something or kill yourself, because it's insulated somewhat. And then it's got the snap-on transformer. That one is like $20.80 to get that. And the one I bought, because I was cheap, I bought one for around $14 to $15, and it came with a solid transformer and a board that was not in a case. So that I'll have some more information if maybe next week I will have tried enough of this. I could say, here's what it's putting out, this is what it's telling me, and so forth. Now, I don't know that I've got anything else that I've done. I did more research on LEDs, and I've done way too much research on these power converter or power monitor boards. But I think it's the point where, I just need to hook it up and verify I'm getting numbers out, and that'll give me more inspiration to do something. So it's just a matter of picking a microcontroller, hook up to it, or use the USB cable and just plug it in a laptop, or I could just plug it into a Raspberry Pi at that point, and either have it log data or have it connect to my home network and send it to another computer to do whatever I want with it. And I think, I just look and see if anything else interesting. I don't see anything, so I'm going to say I'm done, and I'll turn it over to Al.
Okay. A few posts in Zoom, just touch on those briefly.
That's in Slack.
You're
Not
right.
Zoom.
Thank you for that. A week ago, Bob had mentioned something called WebRTC. I had never really messed with it, and I had another way to control a couple of servos from a web interface, and there was a little bit of lag in it, and Bob had done some research, and this WebRTC was supposed to be more real time. And so I'd spent a little time trying to figure that out and come up with a web interface using that. And lo and behold, it was a little bit faster. So I think as I move forward, I'll probably try to use this sample that I crafted and sort of the desk check, non-scientific testing was about a quarter of a second lag, where previously the best I could do is about a half a second lag between the time I would change a servo setting, visually, personally see the change, and then see the change appear in the video. The video was lagging, a little bit. So anyway, good find, Bob. We'll see if we can use that going forward.
Does WebRTC, is that just video that's sending, or does I let you do control also?
You can create a data channel. So I have all three of these elements. So the video is here, the commands going to the servos is another channel, and then I've got what I just listed here is telemetry coming back, is all via an RTC. I'm going to call it a socket, but I don't know if that's the right language to use or not. But it's on this 8080 channel. He says that with hesitation because I'm not sure if it's the right language.
That's a port.
Yeah, okay, port. Let's see. The other thing is Jeff mentioned still mucking around with this LED. And so I did a little testing, and there's a post out there on Slack. Oopie daisy. And so I had an Arduino driving the LED driver.
Can you go ahead and run
So,
that video?
yeah, so it's running.
We're not seeing it.
You're not seeing my video.
No, you're
Ah,
not
but
sharing your
darn.
screen.
Thought I was,
I
hold
just I
on.
just see you, so you're apparently not sharing your screen.
Let me go back to sharing. How about now?
Okay, now we can see the video is running. Okay, and then take your cursor and draw around the light so we know what we're supposed
Yeah,
to be
so
looking
the
at.
light is here, and it's just being driven by an Arduino, and it's the LED driver that I purchased. So forget what I just said on there. So that circuit was not basically, it was, well, shoot. Didn't have an RPi, I had an Arduino, just moving the pin high and low. And that says 5 volt. It wasn't that circuit. It was this circuit using this, which is one of these LD2635MA LED controllers. And where this picture has this 1R00 on it, mine has a R560 there. So again, Jeff mentioned somewhere about supposedly 350 milliamps constant current coming out of that. So using the 1 watt LED, you're not going to land a plane in the brightness of that LED, but 10 or 20 feet away in really, really bright sunlight, I I could see that. So I think I'm going to move forward trying to make that work. And
Did you
so
try aluminum foil inside of your?
no, no aluminum foil yet. I will, but um, I just wanted to do something outside to see if it was even going to be remotely close. So
Okay, that may or may not help. You'll have to try it and see what it does. It'll certainly stop bleed through from one level to the other.
and so I was working on, sort of a crude diagram of what all that's going to look like, and then was messing around with putting it on an actual board, and just to get my head around this because I'm still not confident with exactly how I'm going to do this. But and this LED comes in a couple of different pieces, but it's got this base and the tower, the light tower, and I was trying to like, oh, I'm going to have to I have 10 small wires going through this, and I'm like, well, why do I even need this piece? Because once I mount it, um, I don't think I need that. So I'm back to sort of like just having the drivers and the board together. And then I was like, well, maybe I can just use one of these smaller boards and get my 5 drivers on there and put it in a box. And so where I was before the call started was just using Fusion 360 to size up a box to put all this in. So
So on a
that's
related note,
that's where
those
I'm at the moment.
you've got those four colored lenses stacked up there. Have you seen anywhere where you get a clear one of those? I don't know what to search for. I go look at Amazon. I can't find anything that's close to that.
You mean just like one lens that's clear?
Yes.
I haven't looked. And no, I've not stumbled across something like
Okay.
that.
That's the other thing I was looking for in Dollar Tree. I was looking at all their Halloween stuff, and they have something they called it a flared candle or something. And it was a thing about 3 inches tall, and it had an LED in the bottom of it. It had like kind of stripes on the side, kind of an iridescent thing. I didn't know if I wanted to spring for $1.50 to take that home and try it on my LEDs. So, but that might work well. But I just, I go to Amazon, look for this stuff, and I don't know what to call that. And yeah, I'm sure it like thing I just discovered. If you search for 3 watt driver as opposed to 1 watt driver, you get extra stuff showing up that they wouldn't show you before. So I was trying to find those lenses and I can't find. The closest thing I found was on like trucks. This like 50 years ago they had these like a turn signal. You'd buy it and it would
Yeah.
be have a bulb in it and it had this plastic kind of a pointy plastic thing on it. Well, it turns out you can buy those that have LEDs in, but they're a lot of money, and like they either sell those in red or in clear. I thought, well, that might work, but again, back to my thought about here's the dome off a standard household LED, and then there's a smaller one from a little 1.2 watt LED. I still might just put those on top of my LEDs and go with those, and that seems to you put enough light through these and it glows really well. So
Yeah, you might have some luck looking around for trailer lights. Um, I don't know.
see the modern ones just have a bunch of LEDs, just a piece of plastic over the top. So it's not necessarily, I
Yeah.
just again, like we've been trying to do, I just want a single LED. I want to scatter the light to make it, visible from the side.
Oh, they even have
Anyway,
a
if
blue one.
anybody comes up with a clever way to search for this stuff, I'd like to hear it.
Get a an old school turn signal light. I just had as you were talking, I had the thought of maybe there was a trailer lights have those lenses on them, and that might be something to consider as well. How do I get back from sharing? Oh, there we go. So anyway, that's where I'm at, still mucking around with this damn, it'll be the most expensive light ever based on the amount of time it's consuming.
Do you recall seeing, I don't know if they make these anymore, but you could get a light to put on top of your car that would have like an incandescent light bulb in the middle. And they had a mirror at a 45-degree angle and a motor on top of it, make it spin around like this. So it was actually like a lighthouse. The thing would go around and reflect the light out. And that way you could put that on. You wouldn't necessarily have to flash your LED. You just simply turn it on. And as the thing goes around, it would point out a beam as it goes around. So I was thinking maybe experimenting with that. So I'd have to get some kind of motor to put on top and find some kind of mirror that I could put inside to make it do that. And so that might be another way to make that work. Might be a little more kludgy, but
Yeah, the notion of
I'm going to put it on pause a second. Okay, go ahead.
well, I was just going to mention you had said something about revolving lights, and this is one that came up in a search, and
Wow, I'm not seeing anything. I got a black screen.
huh. So I'm going to stop share and reshare. Do you still have a black screen?
No, now it's working.
Do you see that when it comes up?
Yeah, I see that. Now the problem with rotating the light is you're going to have to get slip rings or something to control that, which it's not the end of the world, but
No, I was thinking you wanted to spend $387 on a light.
that's probably, except I see Walmart's got it for 169. I should
Yeah,
buy it there instead.
go for them.
But no, the one I was thinking of, it had, here, that purple one on the right. That's closer to what I'm thinking, where they've just got it looks like they got a light in the middle and then some kind of reflector that rotates in it. So they did it the other way around. They have the light coming in from the top and then the motor is on the bottom to spin it. And if they just had better pictures, that would keep everybody happier too. But if you could go to say YouTube and say,
Oh, does this rotate this one?
another thing they'll do, they'll have, like I was saying, that you could buy the ones with multiple boards in, and then they'll just through software. Well, here, here, when I was talking about this bulb here, this one, if you sequence them as they go around like that, it looks like it's a rotating light. So that's another way you could do that. I was looking at it as like police lights or something. We're doing it that way.
Anyway, that's it for me.
Okay, I'm gonna call it quits too.